Okay, I've begun the recording. So let us begin now. Okay, so I hope you can hear me. Also, can you see the screen? Can you see the screen that I'm sharing?
Yes, sir.
Okay, good. Yeah, so good evening, everyone. Today will be the solving session for week 2, and the topic for today's session is set theory. If any of you did not attend last time's class, my name is Bhavya. So I'll be holding the problem solving sessions on Tuesdays 6 p.m. Okay, to 8 p.m. Okay, and today's topic is set theory. I'll show you how to solve a few problems on set theory. Some of them may be, most of them will be quite simple, but a few of them could be slightly challenging. So we'll learn to tackle them one by one. So let us begin. So what is a set? Firstly, I mean, a lot of you must have seen set theory from, elementary set theory from high school mathematics itself. So set is simply a collection of elements. And how do we represent those collection of elements? We actually represent them inside curly braces, okay, and elements separated by commas. Okay, this is one way to represent them. So here is an example. Okay, a set containing 1, 3, 5, 7. Okay. Otherwise, here I have a set of famous scientists, Kalam, Sarabhai, Bhabha, Raman. These are elements. These are also called members of the set. Okay, so this is the set. These are the members of the set. Next, this is what can be called the list form or tabular form. Okay, another or roster form. Okay, another way to represent set would be this way. Okay, you must have seen it in the lecture videos. The other way is x, okay, the set of all elements x, such that x is an odd natural number and x is less than 8. Okay, so this is what is called, okay, the set builder form, and this is much more elegant, as you can see it. If I had to list them one by one, I can write the set as follows. Okay, an odd natural number. See, assuming natural number starts from 0. Okay, so natural numbers would be 0, 1, 2, 3, and so on, right? But we are saying only the odd natural numbers. So 0 is not an odd natural number. 1 is the first odd natural number in the list. 2 is not a natural number. 2 is not a odd natural number. So we'll be choosing 3, and then 5, and then 7, and 9, and so on. This is my set of all odd natural numbers. But they are saying only those numbers, okay, which are less than 8. So which numbers do we choose? 7, 9 should not be chosen. Okay, so 9 must not be chosen. So an equivalent way of representing the set builder notation is by listing out like this. But as you can see, it is not always easily possible to list all the numbers. So set builder notation is often quite useful, okay, as we'll see later on. Another important notation that you will see being used is this, which looks like an epsilon symbol, and this shows belongs to. Okay, for example, in this set, okay, 1, 3, 5, 7, which I will call this set as S. Okay, my question is, 3 belongs to S. Is this true? This is my set S. Okay, and my question is whether 3 is in S. 3 belongs to S. So 3 is a member of S, right? Yeah, Akanksha. So yeah, so what is the explanation? 3 is a member of X. We can clearly see 3 inside. Okay, so clearly this is true. However, if I write 8 is in S, now this is clearly false. Okay, another way to state, but what is true? this is true. Okay, and what does this symbol mean? Does not belong to. It does not belong to S. This is what it signifies, and this is true. Okay, you can think of it being like analogous to equals to. Okay, equals to and not equal to symbol. Now, those are some elementary things. Now we'll look at some problems involving the cardinality. What is cardinality? You can think of cardinality, another name for cardinality, to be the size of the set. Okay. Now, what is the size of the set? The number of members in a set is the cardinality. As simple as that. For example, here we have 2, 3, 4, 5. Now, what is the cardinality? 4. There are 4 elements clearly, right? And 7, 3, 2, 1 minus 120. What is the cardinality here? 1, 2, 1, 2, 3, 4, 5, 6. So there are 6 people out here. So the cardinality is 6. Now I'd like to ask a question. Okay. So tell me the cardinality, okay, of this set, and it is represented by these 2 lines to the left and right. Tell me the cardinality of this set. Okay, A is equal to 2, 3, 5, 3, 8, 7, 8. Okay. So if you've seen it intellectually, okay, Akanksha says 4. Others, Lakshmi and Divya, what is the cardinality of this set? Okay, am I audible, Divya and Lakshmi? Okay, Divya says 5. Okay. Akanksha says it's 5. Yeah, okay. Lakshmi says it's 7. Okay. Taswar has joined. Sadat has joined. Okay. Okay. So, okay, Akanksha has given a set. Okay, Lakshmi says 7. Okay. To the people who've joined just now. Okay. Hi, Taswar and Sadat. I was teaching the cardinality of the set. Okay, cardinality is simply the number of members in the set. So here there are 1, 2, 3, 4 members in the set. 2, 3, 4, 5. So the cardinality is 4. And here there are 6 members in the set. As you can count, there are 6. The cardinality is 6. The question that I asked was, what is the cardinality of this set? What is the size of this set? And okay, now I'll tell you. One thing you should notice, okay, for any set, okay, okay, 2 equal, okay, elements are counted only once, or in other words, there are no duplicates. Okay, so here you can see that A can be rewritten as 2, 3, 5. Now 3 is a duplicate out here. This is not, allowed in a sense in sets. So 3 is a duplicate here. It is treated as a single element. This 3 and this 3 is treated as a single element. So 3, I don't write it again. Okay, then I write 8 and 7. Okay, and this 8 has already occurred in the set, so I don't need to write it once again. Okay, so what is the size of the set? The size of a set is, the size of a set is 5. Now Lakshmi and a few people earlier have said 7, right? Now that is true in a structure called multi-set. Okay, That is true in a structure called multiset, which is out of scope of the NPTEL course. But you can still look it up in the internet and see that multiset is actually talking about sets which allows duplicates this way. Okay? But if this is a set, the cardinality, just remove the duplicates, okay, and the cardinality is equal to 5. Getting it? Okay. So let us move on. Okay. So yeah, let us look at this question. The question says, what is the cardinality of the set of odd positive integers less than 10? Okay. So I'll let you guys think for a while. Okay, I'll give you a few seconds to think about it. What is the cardinality of set of odd positive integers less than 10? And if you think you've got the answer, please post it. Okay, 5. Divya says 5. Okay. So let this set be called A. Okay. Akanksha says 5. So let this set be called A. Now A is nothing but x such that x is odd positive integer and x is less than 10. So let us look at it. A can be listed as follows. Okay. So 0. So okay, integers can be negative also, but we are talking about positive integers. So even 0 is not positive, right? It is non-negative, but it is still not positive. The first positive integer is 1. And is it odd? Yes, it is odd. And is it less than 10? Yes, it is less than 10. So it is a member of the set. Next, 2 is not even odd. It is positive, but not even odd. So 2 is not a member of the set. Next odd positive number is 3. Next we have 5. Next we have 7. And next we have 9. If we keep going, we get 11 and so on. But remember, 11 is not less than 10. So it does not satisfy the constraint. It does not satisfy the requirement of the set. So 11 is not a member of the set. So this is my set A. So size of A is 1, 2, 3, 4, 5. 5 is the answer. Yeah, I think all of you have answered correctly. So size of A is 5. The cardinality of A is 5. Good. Now let's move on. The question says following. The members of the set S equals x such that x is square of a this should not be integer, should be negative. Non-negative integer and x is less than 100. So again, I'll give you a few maybe a few seconds, okay, to think about it. And which do you think is the correct option? Please try. Okay, Divya. B. Lakshmi 2 says B. Okay, what do the others think? Okay, Akanksha says B. Okay. Okay. Let's see. This too is similar to the previous question, right? We just need to list it out, right? X is the square of non-negative integer, and x is less than 100. So let's forget about the square thing. Let's forget about the square. Okay, just think of all the non-negative integers which are less than 100. Okay, so what are the non-negative integers that are okay, so this x should be less than 100. So yeah, let's do it directly. S could be, okay, so S could be the square of a non-negative integer. So the first non-negative integer is 0. Square of a non-negative integer is 0 itself, and it is less than 100. Next we have 1, which is the next non-negative integer. The square is 1 itself, which is less than 100. It is a member of the set. Next we have 2 square. What is 2 square? 2 square is just 4, and 4 is less than 100. So this property is satisfied. It is a member, and we keep going on. Next is 3 squared, which is 9. 9 is less than 100. Good. Next is 4 squared, 16. And next we have 5 squared, which is 25. 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81. 10 squared is 100. And we can keep going on. 11 squared is some 121 and so on. But remember that we want the squared value x, okay, to be less than 100. And this gets violated at this point. 100 is not less than 100. 121 is not less than 100. So these are not members of the set. So what do you have? You remove these guys, okay, and this is your answer. And if you check, the answer is simply B. Good. So here too, I don't think anyone has a doubt. Everyone has answered it correctly. So let's move on. Let us talk about subsets. I'm going in the same order as which the NPTEL videos were going on. Okay. So let us look at subsets. Okay. Subsets talk about what are called containments. Okay. Now the question is, we have a certain notation which is this sort of C symbol under which there is a long line, which means subset of. Okay. Now we say A is a subset of B if all the elements in A are in B. Okay. For example, here I have a set A. Now what does this box A contain? A contains 1, 20 and 4. And B contains what? 1, 2, 4, 32, 23 and so on. So the question is A a subset of B? Yes, because all the elements 1, 24 in A, all the elements in A, okay, are contained in B. 1, 2, 4, 32, 23, 21, 20, 21 are the elements in B. 1 is contained in B. 20 is contained in B. So 1 and 20 are contained in B. 4 is also contained in B. So this is true. Now let's say A equals A prime equals 21, 32, 7. Now 21, okay, now the question is this true? Well, 21 is contained in the set, 32 is contained in the set, but 7 is not contained in the set. So all the elements are not contained in the set, so it is not true that A is a subset of B. The answer is no. Okay. Now I'd like to ask whether B is contained in B. Can someone tell me? And also, these are the two questions I would like to pose. Is B contained in B? Okay, the set B contained in B, and is the set empty set, okay, contained in B? So this empty set can also be represented by phi or phi, whatever you call it. So is the empty set contained in B? Okay. another question. So Divya says both are true. Okay. Okay. Yeah. Well, if any of you are confused about this, okay, it is true that B is contained in B because what is the definition of subset? All the elements in B should be contained in B, and that is true, right? Any element in itself is contained. Any elements, yeah, within itself is contained in itself, right? So this is true. And what is this empty set? Empty set can also be written as phi. Now, is the empty set contained in B? The question is, every element in the empty set should be contained in B. But is there anything contained in the empty set? No, right? Nothing is contained in the empty set. So these kind of statements are what are called vacuously true in mathematics. Okay, so this is vacuously true. We cannot say it is false. Remember, we cannot say it is false because phi does not have any elements itself. So we cannot provide an element, okay, which belongs to phi but does not belong to B. So therefore the statement must be true. So the empty set is always contained within the set. Okay, these are some observations that you might find useful later on, especially when we talk about things like power sets. Okay, I hope there are no doubts about these two facts. Okay, these are facts. Okay, yeah. So yeah. Now I'd like to discuss some set operations. Okay? You can do some kind of operations between two sets. Okay. So let us say, okay. Oh, sorry. I think you've seen in the videos that you first define something called a universe. A universe is the set of all elements that are that exist in the current scenario. So it's called the universal set or the universe. Okay. Now let's say you have two sets A and B sitting inside, and these A and B may or may not share some elements in between them. Okay. So now, okay. Now let us say this is my universe. Okay, my universe are all natural numbers. Okay, assuming natural numbers start from 1. Okay, or all positive integers. Okay, until 10. And what is A? A is 1, 2, 3, 4, 5, 6. And what is B? B is 5, 6, 7, 8. My question now, okay, or what I'll introduce now is what is called the union of the set. So a union are all the elements, okay, in A or in B. That means as well as in B. If I have to represent it in the Venn diagram, this is my union. Everything. So now tell me, okay, here A is 1, 2, 3, 4, 5, 6 and B is 5, 6, 7, 8. What should be A union B? Okay, again I repeat the question. A is 1, 2, 3, 4, 5, 6. B is 5, 6, 7, 8. What should be A union B? So A union B should be all the elements which are in A as well as B. Okay, that's what Reza says 1, 2, 3, 4, 5, 6, 7, 8. Right. It should be all the elements that are in A as well as in B. Yeah, good. So 1, 2, 3, 4, 5, 6 are in A as well as the elements which belong to B. B has 5, 6, 7 8, but remember about the point I said earlier about sets and multisets and so on. So I don't need to keep writing 5 6 again, because 5 6 are already there in the set. Okay, so 5 6 7 8, right? So this is your set A union B. Okay, now let us talk about the intersection. Okay, what is A intersection B? A intersection B are all those elements, okay, which belong to A as and X belongs to B. Okay. Oh, okay. Sorry. As well as is a bit confusing, so don't. I will not write as well as. Okay, we'll keep it at or. I think or is less confusing, because as well as is more applicable here, I think, in the intersection. Anyway, X is in A and X is in B. Okay, so in the Venn diagram, if you see carefully, these are the elements which belong to the set A, and these same elements are the elements which belong to the B also. So this area is what is called, the shaded portion is what is called the intersection. So similarly, okay, I ask you now, this was the set I was dealing with, yeah, right? So A is 1 2 3 4 5 6 and B is 5 6 7 8. Now what could be the intersection of these two sets? In other words, intersection is simply the set of those elements which get shared between two sets. Okay, or you can think of intersection as overlap. Okay. Okay, Akanksha says 5 6 thus versus 5 6. Yeah, okay, good. So just see where the overlap happens between A and B. See, A is 1 2 3 4 5 6 and B is 5 6. The two share elements 5 6, right? So these are the position where it shares. So A intersection B is 5 6. 5 6 exists here, and you know, like 1 2 and so on here, 7 8 and so on will be staying in those two different places. Good. Now complement. Let us talk about complement. Now complement is interesting. So complement are all those elements, okay, which do not belong to the set itself. It is shown by this C, or sometimes it is also notated as, you know, A bar. Okay, all those elements which do not belong to the set itself. So, or the universe minus A. So I'll show you what it looks like in the Venn diagram. Okay, so this is A, right? What is A complement? I'll write it with a different color. Maybe this, no, maybe this color. So A complement, okay, it's quite colorful. Let's use brown, pink, green. Let's use green. Okay. So these elements which are outside A, remember it can overlap with this portion of B, because we just care about those elements which are outside A. So these elements, the green shaded portion, are all in the complement of A. So now tell me, if this is A, what should be A complement? Look at the universe. Okay, look at the universal set and tell me what are the what is A complement? Akanksha says 7 8 9 10. Okay, this versus 7 8 9 10. Right. So if you look at the Venn diagram, 1 2 3 4 5, 6 7, sorry, if you look at the Venn diagram, 1 2 3 4 5 6 all live inside A. 1, 2, 3, 4, 5, 6 and all live inside A. And the remaining 7, 8 stay here, and 9, 10 stay here, and so on. So whatever is in the green shaded area are 7, 8, 9, 10, right? So A complement is simply 7, 8, 9, 10. This is how you could visualize it using the Venn diagram way, or simply you can simply do this. Remove all the elements which are in A from U. Okay, I didn't do it that way because I have not explained set difference to you yet, which is the next point of the topic. What is set difference? Okay, set difference of A and B, or A minus B. So so these are all the elements which are in A, but they are not in B. All the elements which are in A are this, and which are not in B, okay, are these elements. Or another way you can see it is you are subtracting the difference. Okay, you are removing B from A, all the elements which are common between them. So this shaded area is your A minus B. So you are removing that chunk of B from A. Okay. Now similarly, if we see here between A and B, you can see that 5, 6 is shared between them, and you are removing that chunk from A. Okay, you are removing this 5, 6 chunk from A. So what do you get remain? That remains is 1, 2, 3, 4. Let me write it down. Okay, A minus B is simply 1, 2, 3, 4, 5, 6 minus 5, 6, 7, 8. Okay, and I remove all the elements that are in common from the first set. So 5 and 6 are common. Okay, I remove them, and 7, 8 were anyway not there in A, so I don't care about that. So 1, 2, 3, 4 is my set difference. Now we have a slightly different kind of, I hope that was clear. Okay, now we have a slightly different kind of difference, which is called a symmetric difference. Okay, now this is, when I write it in the Venn diagram, it becomes more clear, but I can write it as follows: X is in A, X is in B, but X is not in the intersection. In other words, this is what is called the symmetric difference. Okay, those elements which are in A, which are in B, but not in both. This is what it signifies. So take the union and remove all the elements which are in common. Okay, so let us do that. Yeah, in this example, can you tell me what the symmetric difference, which is denoted by the triangle? Okay, this triangle between A and B. Now can you tell me what the symmetric difference between them are? 1, 2, 3, 4, 5, 6 and 5, 6, 7, 8. What is the symmetric difference between A and B? 1, 2, 3, 4, 7, 8. Okay, 1, 2, 3, 4, 7, 8. Okay. Divya and Akanksha say 1, 2, 3, 4, 7, 8. Yeah, good. The idea, looking at the Venn diagram, we can clearly see that as long as we can remove all the shared elements, we'll get our answer. Right. So clearly 5, 6 is shared between A and B. So just remove whatever whatever they've shared, okay, and just combine them. So we are left with 1, 2, 3, 4 and 7, 8. So that is your answer. So whatever the share is 1, 2, 3, 4, 7, 8. Okay, good. Now few things. Please note that set difference, you can represent it this way: A intersection B complement. You can think about it offline. I'm not going to explain because it was done in the lectures. Okay. A, but if you have doubts about it, I can still explain it right now. Okay, but you can try it yourself using Venn diagrams. Okay, please note. Okay, this is an important property that you will use in set theory a lot. The other thing is that symmetric difference can be represented this way: A minus B union B minus A. This is very clear from the Venn diagram. This is A minus B and this is B minus A, right? So just combine them using union and you have this symmetric difference. You can represent it this way, or another way to do it is A union B minus whatever is shared, A intersection B. This is another way. I think it's mentioned in the lectures also. Okay. Okay. Next, the complement of, if you complement a set 2 times, you get itself. Okay, if you complement a set 2 times, you get itself. So that too you can, it is quite intuitive. You can try it yourself. Take a set, take its complement in the Venn diagram, and then take its complement again. You see that you obtain the same set once again. Okay, so please note these things. Okay, and try to get a feel about these observations. Okay, it'll help you. Okay, now let us solve some more problems. Okay, so here the question is as follows. Let me increase the size. Okay, good. The question is, let A be the set of English words that contain the letter X. Let B be the set of English words that contain the letter Q. Express each of these sets as a combination of A and B. Okay. So firstly, the question says, okay, I'll do the first one. Okay. The set of English words that do not contain the letter X. So let me specify the universe first. Okay. Let the universal set U, okay, be X such that X is an English word. So the universe, in other words, is just the set of all English words that are there in the world. Okay, the universe is something like an English dictionary. Okay, so our universe is that way. Now, what is the question saying? The question is saying, let A be the set of English words that contain the letter X. A contains the letter, set of all English words that contains the letter X. So words like, 6, okay, and what are other words that contain X? Let's say latex, okay, and so on. Okay, these are all contained in A. And B be the set of words contain the letter Q. There could exist, right? I mean, something, I don't, there's nothing that comes to mind which has both X and Q. Okay, one word is, a novel called Quixote. So this word should be contained in, both of them. I think Quixote, QI, yeah. So this is, although it's a name of a person. Anyway, and here B contains all the letters that have Q, for example, quilt, queen, and so on. So there could be some things that they share. Okay. Now our job is to represent them in a set notation form. So the set of all English words that do not contain the letter X are all the words. Okay, so part A. Okay, let me call this set A, not A. Okay. Okay, the set of English words that do not contain the letter X are X such that X does not belong to A, right? All the words that do not contain letter X, and all the words that contain the letter X are A, exactly, which is nothing but the definition of A complement. So this is the set notation form. Next question, the set of English words that contain both X and a Q, both an X and a Q. Okay, so I mean, it is pretty evident from the question itself. Can you tell me how I can represent it as a combination of A and B? So A is the set of all words that contain X, and B is the set of all words that contain Q. I want B, the set of all English words that contain both X and Q. Okay. Okay. So let me repeat the question. I want all the set of English words that contain both X and Q. And this is exactly the section. Yeah, Akanksha has answered it. This is exactly the section I want. But what is this section? This is simply A intersection B, right? So the question for the answer for B is A intersection B. Now C, can you answer C? Part C, the set of all English words that contain an X but not a Q. Okay. Divya, Akanksha, yeah, good. The set of all English words that contain X but not a Q is exactly this section. Okay. Okay. So it is exactly. Moment, I'll remove this. Okay. Anyway, it is exactly this section, right? But not a Q, because B's chunk says that it contains a Q. So the answer is A minus remove all the letters that contain Q. Okay, because of this. The next part, D. Can you tell me the set of all English words that do not contain either an X or a Q? Okay. Akanksha says A union B complement. Okay, yeah. So, set of English words that contain either an X or a Q. So, contains X or Q is simply the set A union B, right? So, does not contain, we are saying. So, does not contain X or Q is simply the complement. All the words that are sitting outside, right? So yeah, this is your answer. Good. Now the next part, the final part of the question: the set of English words that contain an X or a U but not both. Now we've seen this before. So think of the Venn diagram and how this plays into. Yeah. Okay. So this is, if you see it in the Venn diagram, it says does not contain, that contain X or Q but not both. So this is the elements that contain both, which I do not want. Remember, I just want the parts of the set that contain either of Q or X but not both. So this is what I want. And what is this called? This was called the symmetric difference. Symmetric difference B. which you can also write it as, A union B minus A intersection B. This is also a valid answer, but collectively it's called. So I hope, yeah, Akanksha, yes, good. So I hope others are also fine with it so far. Taswar, Reza. Okay. Yeah. So good. Let's move on. So this is a conceptual question. Okay. This says A is a subset of B is a subset of C, then the cardinality of A union B union C is equal to. So I'll let you again think about this question. So I mean, it always helps to use Venn diagrams. So what is the cardinality of A union B union C equal to? Is it A, B, C, or none of the above? Okay. Taswar says C. Divya says C. Akanksha says C. Okay. It's good. So yeah, if we imagine it, okay. So A is a subset of, okay, I think I need to make a bigger diagram. So let me use this tool. So A is sitting inside B and B is sitting inside C in turn. So A is sitting inside B is sitting inside C. So now what do you have? What is A union B union C? It is a set of all elements that are contained in A also and B also and C also. I mean, it is a combination of all the elements sitting inside the three sets, which is nothing but this shaded area. But what is this shaded area? The shaded area is nothing but C, right? So the answer is C. Okay. Union in Venn diagrams is simply shade all the regions. Okay. But here, I mean, all the regions are contained in C itself. So your answer is C. Okay. Moving on. Let's do the next set of things that were done in the lectures. Okay. And at this point, things will get a little bit non-trivial. So, De Morgan's law says the following. Okay, De Morgan's law is used to remove complements. Okay, which you remove large complements. Okay, what do I mean by large complements? For example, the following. This complement is not just for A or just for B. It is a complement for A union B. Now, how do you do that? De Morgan's law says that I simply change the union to an intersection and then complement A and complement B. So A union B whole complement is just A complement intersection B complement. Now what is the second part of De Morgan's law? It says that A intersection B whole complement, okay, intersection changed to union. Remember that. So A intersection B whole complement is equal to A complement union B complement. Okay. So the complement moves inside and union becomes intersection and vice versa. I'm not going to do the proof of this because this was already done in the lectures. So please revisit them. Or if you want me to explain that and you had a doubt during the lecture, then I am happy to explain it to you. But I'll do something slightly extra. Okay, this is what is called the distributive law, and it is still pretty simple. Okay, what does the distributive law say? Or even before showing the distributive law for sets, I'll just show you how distributive law works for integers, right? So let us say I have 3 plus 7 times 2. Or either Let's do this. 3 times 7 plus 2. Okay. It is same as, 3 times 9, which is 27. Okay. Or I can do this. I can distribute 3 inside. 3 times 7 plus 3 times 2. 3 times 7 is 21 plus 6, which is nothing but 27. And we've done this all over high school mathematics, right? We've seen it all over the place. One moment. Okay, we've seen it all over the place. So what is the distributive law for sets? Simply take the plus minus as union and intersection. Plus and multiply as union and intersection. So A intersection B union C. Okay, remember B union C is inside bracket. So A is intersecting with this whole thing. A will get equally distributed, just like in the case of integers. Okay, like 3 multiplied inside. Similarly, A will multiply inside and it will become A intersection B. First it will intersect with B union, then it will get distributed to C. A intersection C. This is the distributive law. The second law is simply for the case of A union B and B intersection C. A will get distributed equally. In other words, A will get distributed with B first. A will get union with B first. A union B intersection. Okay. Intersection. A will then get distributed to C. It will become A union C. This is what is called the distributive law. And you can, use Venn diagrams to see it also. For example, the first one, A intersection B union C. What is B union C? B union C is this area. Okay, this area. And what is A intersection of this is simply this area. Right. So now we know what the area we are looking for is. And if you look at the RHS, it says A intersection B union A intersection C. So what is A intersection B? This is, this is A intersection B. And what is A intersection C? A intersection C is this. So both are same. So yeah, you can prove it using Venn diagrams also. So now that we've seen the distributive law, okay, let's try to solve this question. Okay, show that. Okay, let me try to increase this. Show that if A and B are sets, then A minus whole of A minus B is equal to A intersection B. So to show A minus B is equal to A intersection B. Okay. So what is this? What is LHS equal to? Remember that A minus B is equal to A intersection B complement. We saw it before. Okay. LHS can be written as A intersection A minus B whole complement. Okay. Now let us use the same rule again, because there is a set minus here, which is nothing but A intersection B complement whole complement. Now can you tell me what law I should apply? What rule I should apply? Distributive law, De Morgan's law, or just one of the two. Should I apply distributive law or should I apply De Morgan's law? So this is the expression I have. Okay, I want to simplify it, and these are the two laws. So one is to bring complements inside, and one is to distribute things inside. So De Morgan's law. Okay. Okay. Divya says De Morgan's law. Does anyone disagree? Okay. I think no one disagrees. Good. It is De Morgan's law, Divya. So why is it the case that we are using De Morgan's law? Why I could have said that, oh, okay, I'll distribute A inside. But remember, there's a complement sitting out here. Whereas if you look at distributive law, there is no complement sitting here. So I cannot use the distributive law directly. So first what I'll do is, I'll use De Morgan's law to bring this complement inside. Okay. Which is, so I'll write it as, so I will not use the distributive law, I'll use the De Morgan's law. So A intersection turns into union, A turns to complement, and B complement turns to complement. Okay. Now remember, okay, this is by De Morgan's law. Now remember, a set complemented 2 times is the same set itself. I showed it to you earlier. So B complement is nothing but B. A intersection A complement union B. Right. Now if you see it, it is in this nice form. It does not have complement on top because of due to De Morgan's law. Right. Thanks to it. And it is in this nice form. Why is it nice? Because now we can apply the distributive law. So we can distribute this A inside. So let us use the distributive law. It is nothing but A intersection A complement union A intersection B complement. Not B complement, B. Now can anyone tell me what is A intersection A complement? Think of it logically.
Empty set, sir.
Yeah, Divya?
Empty set.
Empty set. Right. Good, because the explanation is that A is sitting as a set in the universe, okay, and A complement is outside, and A is this shaded region. Where do they overlap? They do not overlap at all, right? By looking at the Venn diagram, we see that they don't overlap at all. These are exactly the sets that don't overlap with each other. So they do not overlap anywhere. So their intersection, okay, their overlap is nothing. It's empty, equals to empty union A intersection B. Now, if you union anything with the empty set, if you combine anything with the empty set, then you whatever set you combine it with the empty set, you get the set itself, right? Logically. So you have A intersection B. I hope it is clear so far. So this is how we achieved it. Okay, and this is by the distributive law. Okay. So simply always remember that if you see a huge complement outside some combination of sets, some intersections and unions, just apply De Morgan's law. It makes things much simpler. Okay, and you see that there's no complement sitting inside, and something is intersecting with the huge block out there. Just apply the distributive law. Okay, so is there any doubts yet? Few people joined just now. Would you like me to explain again? I would be fine with it. Okay. Okay, I'll continue. Okay, the source says yes. So would you like me to repeat, or are you saying yes for the repetition, or yes for moving on? Okay, I'll just repeat once. So the question said the following, okay, prove that a minus whole of a minus b is equal to a intersection b. Okay, so this is what we need to show. So remember, firstly I use this particular property. Okay, a minus b is nothing but a intersection of b complement. Now I apply that property here to this minus a minus b is equal to a intersection a minus b whole complement. I'm applying the complement here and turning this into an intersection using that property. Okay. Next, what do? I still have this set minus, right? That too I'll convert it into intersections and complements. How do I do that? Using the same property. I have an a minus b here. I'll just simply turn it into a intersection b complement. So I turned it into a intersection b complement. Now look at something. I cannot use the distributive law here because there is a complement sitting outside. And distributive law is only when, you know, these brackets don't have complements. Complements create a problem here. So in such cases, when you have big chunks of intersections and unions with complements, always use the De Morgan's law. What does De Morgan's law state? De Morgan's law states that, you know, if there is a complement outside the huge chunk, I can bring the complement inside at the cost of changing, you know, unions to intersections and intersections to unions. Okay, good. Now what do? See, this chunk I want to change, right? So what do? I change the intersection. Okay, I change this intersection to a union, and I bring this complements inside here. To this A, I make A complement. To this B complement, make B complements complement. Okay. Now what I do is, B is complement. Okay, I said it before. If you complement any set 2 times, you get the same set itself. So B complement becomes B. Okay. And A and now you have this A intersection A complement on union B. Now it is in this distributive law form, and you can finally use the distributive law and just distribute this A inside, which will give me A intersection A complement and A intersection B, okay, with a union in between. And A intersection A complement. What is A intersection A complement? It is empty set. If you see the Venn diagram, you know, A intersection A complement is sitting outside A and A is sitting in outside A complement, so they will never overlap. So their overlap is the empty set, and that's what you get here. And you know, union with the empty set will give you A intersection. Union with the empty set will give you the set itself, and you get A intersection B. I hope that recap was good enough. Okay. So do let me know if there was still any trouble here. Okay. Okay. Meanwhile, I'll move on. So another similar kind of a question. Okay. A union B intersection C, B intersection C whole complement, and the complement of that is equal to A complement intersection B intersection C. Okay. Let's try this. Okay. What I need to show is A union B intersection C whole complement and the complement of that is equal to A complement intersection B intersection C. Yeah. So can you tell me again, what law should I use? Distributive law or De Morgan's law? Okay. Akanksha says De Morgan's law. if we assess De Morgan's law. Okay. So yeah, good. See, there are these huge complements sitting outside, right? So I would say you can blindly use De Morgan's law. But if, let's say, this complement was not here, then you could have used distributive law between these two also. But unfortunately, that is not the case. You have a complement here. So what you do is you use De Morgan's law, and this union will become intersection B intersection C whole complement. Again complement, by De Morgan's. Okay. Now what do? Now you see that I have a set complemented twice. I have a set which is complemented twice. Now we know that a set complemented twice is itself, so I can simply remove the complement as follows. Good. Now I can simply, since intersection, it doesn't matter in which order I intersect them. Okay, I don't need to do it first. So this is my answer. This is simpler than the previous one. So I hope there is no problem here. Okay. Everyone fine? Taswar, is it fine? Okay. Okay, good. Now we'll look at the final part of the week's lectures. Okay, based on what is called the exclusion principle. It's also called PIE, principle of inclusion and exclusion. Well, the name seems a bit scary, but it's not very scary. At least in trivial cases like 2 sets or 3 sets, it's not very scary. What the inclusion exclusion principle simply tries to find is it tries to identify a relationship between intersections and unions, cardinalities of intersections and unions. So this is what I want to estimate. Okay, and the union is what I want to know, and but all I know is all I know is the size of A. All I know is the size of A, the size of B, and their intersection. Why is this? Okay. And their intersection. This is all I know. So how do I do that? How do I do that? I use this, which is called the inclusion exclusion principle. The size of the union between A union B is the size of A plus the size of B minus the size of this A intersection B. The proof is by an overcounting argument, and you must have seen it in the lecture videos. I mean, if you have doubts regarding that, I can explain once again, but I'll move on for now. Okay. But what is the inclusion exclusion for A union B union C? Okay, 3 sets. Size of A plus size of B. Okay, there's a slight mistake here. I need to add the size of C also, sorry. Okay, plus size of C minus all the intersections, A minus A intersection B, A intersection C, and B intersection C. Remove all the intersections, or 2 set intersections, and add the intersection of all 3 sets, A intersection B intersection C. Okay, for now I'll focus on the first one. We will solve problems regarding the first one. Okay, size of A plus size of B minus A intersection B. Okay, the question is as follows. Out of 500 owners investigated, 400 owned the car Audi, 200 owned BMW, 50 owned both. Is the data correct? That is the question. So let me make a Venn diagram. So here I have A, here I have B. So what is A? A is all the owners X such that X owns Audi. B is all the X, all the owners such that X owns BMW. Now what are they saying? What is size of A union B? Size of A union B is all the car owners. Okay, they own either Audi or BMW. So we'll assume that without loss of generality. Okay, so 500 car owners. Okay, there are a total of 500 car owners, and out of them 400 owned Audi, 200 owned BMW. So the size of the Audi owners, which is A, is 400. The size of the BMW owners, the number of people who own BMW, is 200, and 50 owned both. What is represented by this? Owning both can be shown by intersection. They own Audi also, they own BMW also. Okay, how many own them? 50 own both. Now the question is the data correct? Can you try your hand at it? I will give you a few minutes. I'll give you a few seconds actually. So can you try your hand at it? The hint is to use inclusion, exclusion principle. Okay, Divya says it's false. Akanksha says it's false. Incorrect. That is quick. Okay. I'll give you a few more seconds for the rest to try. You need to check whether the data is correct. Okay, Tessin also is not correct. Okay, good. So yes, the answer is that it is not correct. Why? Because principle of inclusion and exclusion, PIE, says A union B equals to A intersection size of A plus size of B minus A intersection B. Okay, what is size of A? 400 Audi owners, 200 BMW owners, minus 50 owners who own both, right? What is this equal to? 400 plus 200, 600 minus 50. What is 600 minus 50? 550. Now we are saying the size of A union B is 550. But what do we know? We know that 500 car owners were investigated. But we know 500 owners were checked. And we are getting something more, 550. So where are these 50 owners coming from? There must be some kind of error during the investigation, some kind of data entry error. So data is incorrect. Good. Okay, good. So another question. let A and B be subsets of a finite universal set. Show that A complement intersection B complement. Okay, let me increase the size of this. Show that the cardinality of A complement intersection B complement is the size of the universe minus A minus size of A minus size of B plus size of A intersection B. Now, already by seeing the structure, this reminds you of the inclusion exclusion principle, which is exactly what we are going to use here. But here also we need to use some kind of laws here, okay? And we need to think of this in a slightly reverse-handed manner. So here what we'll use is, okay, Divya has already answered it. But here what we'll use is, we'll use the De Morgan's law. I mean, De Morgan's law is supposed to, some of you may be confused that De Morgan's law is supposed to actually remove complements in big chunks, right? But we can go the other way around also. From smaller chunks, if all of them have complements, okay, we can actually make it a big chunk of a complement. What does De Morgan's law state? States that A union B whole complement equals A complement intersection B complement, right? Which is exactly this. So we'll make it into A union B whole complement. Okay. So LHS equals size of A union B whole complement by De Morgan's law. Good. Next, what do we do? A union B whole complement. Now what we use is, we use the definition of a complement. Okay. What is A complement? A complement is nothing but the universe minus A, right? So, in other words, if this is A union B, okay, and this is A intersection B, this is A union B whole complement, and this is A union B whole complement. This can also be written as the universe, that area can also be written as the universe minus the set A union B whole complement. Okay, or simply by the definition, you have U minus A union B. Okay, good. Now what do you have? Since you know that all the elements, okay, within A union B are also in the universe, you can simply do this. Okay, size of the universe minus size of all the elements in A union B, right? Because everything is contained in the universe itself. So now what you have, you write size of U minus, now I'll use the principle of inclusion exclusion. Okay, A size of A plus size of B minus A intersection, size of A intersection B. What is this? Size of universe minus size of A minus size of B plus A intersection B, which is the answer. And this is by the principle of inclusion exclusion. Okay, this is what the question asked, right? A size of A minus size of B plus A intersection B. Okay, good. I hope all is fine. So let's move on to the next question. I'll increase the size. Okay, in a class of 110 students, X student take both mathematics and statistics. Okay, 110 students. 2x plus 20 take mathematics. 2x plus 30 take statistics. There are no students who take neither mathematics nor statistics. Okay. What is x equal to? Now let us collect all the data. I'll tell you guys to try and solve it, but first let's collect all the data. In a class of 110 students, okay, so the universe is, size of the universe is 110. X student takes both mathematics and statistics. So let A equals to all the students such that X take maths and B be all the students such that they take statistics. So if we see the Venn diagram, yeah, we see the Venn diagram. Okay, this is A, this is B. Some student take maths, some student takes only statistics, some can take both, right? Now, X student takes both mathematics and statistics. The ones that take both mathematics and statistics are these people, right? Which is nothing but the intersection. A intersection B. What is the size according to the question? X students. Next, what is the question saying? 2x plus 20 take mathematics. How many students take mathematics? 2x plus 20. And in our case, okay, how do I write? Okay, let me reduce the size of this. Okay. In our case, the number of people who take mathematics is nothing but size of A. How many? 2x plus 20. And what do they say? 2x plus 30 take statistics. People who take statistics are nothing but the set B. So number of people who take statistics, okay, is the size of B, which is 2x plus 30. There are no students who takes neither statistics or mathematics. Okay, this is a nice observation. Okay, there are no students who take neither mathematics or statistics. Who are the people who take neither statistics and mathematics? Who sit here in the outside part, okay, of this universe? And there are, okay, no people here. If there are no people here, what does it mean? Since no people take no people taking neither of the two subjects, the observation that we can make is the universe is nothing but A union B. Okay, right. Why? Because there are no people sitting here. If no people are sitting here, then the universe is as good as these people. No, A intersection, A union B, because there are no people sitting in the gap. So the universe sort of collapses to these two spheres. But we know that what? We know that the size of U equals 110, which means the size of A union B is equal to 110. Okay. Now what are we supposed to find? We are supposed to find what is x equal to. Now I tell you that you have all the information you require. Please try solving what x is equal to. I'll give you about 1 minute maybe. Okay, Akanksha has already given one answer. Okay, others also, please try. Look at this and try to solve for x. So Sumant has joined right now. Sumant, we are doing inclusion exclusion principle. Okay, and on solving this question, we found these parameters for size of A intersection B, size of A, and so on. And the question is, okay, and this is also the hint now that can you use the principle of exclusion, inclusion, exclusion to find the value of X? Tessin says 29. Okay, Tessin says 20 also. Okay. Here also says 20. Okay. Okay. Good. Yeah. The answer is 20. So last questions. लास्ट क्वेश्चन दिखा दीजिए. तहसीन, तुम्हारा मतलब है प्रीवियस वाला क्वेश्चन जो आपने सॉल्व किया है. ओके, ये वाला तहसीन. ओके ओके, सॉल्व करके दिखाओ बोल रहे हो फिर से?
थैंक यू सर.
हाँ, सॉल्व करके दिखाओ बोल रहे हो या बस ये डिस्प्ले करने को बोल रहे हो?
नो सर, ये कैप्चर करनी थी मुझे.
ओह ओके ओके, ठीक है ठीक है. स्क्रीनशॉट, ओके. क्या कैप्चर कर लो.
कर लिया मैंने सर.
ओह
थैंक यू सर.
ओके, या नो प्रॉब्लम तहसीन. ओके. Okay, so now, yeah, I think a lot of you have tried your hand on it. Okay, yeah, I think most of you have answered it correctly. So we need to find what the value of X is, and we've actually got all the tools we need to do it. We'll simply use principle of exclusion, inclusion, exclusion. Okay, by principle of inclusion, exclusion, what do you have? The size of A union B is equal to size of A plus size of B minus size of A intersection B. Okay, now what is that? Okay, तहसीन, तुमने हैंड रेज किया था, अभी कुछ क्वेश्चन है?
नो सर, मिस्टेक से हो गई.
ओह अच्छा अच्छा, ओके, नो प्रॉब्लम. So now what do you do that? Now how do you do? A union B, size of A union B is nothing but 110. Size of A is nothing but 2x plus 20. Size of B is nothing but 2x plus 30 minus size of A intersection B. What is size of A intersection B? Is x. Now 2x plus 2x is 4x minus x is 3x. 20 plus 30 is 50 and 110 here. So now what do you have? 3x is equal to 110 minus 50, which is equal to 60. X equals 60 by 3, which is nothing but 20. Okay, so option B, 20 is the correct answer. Good. So most of you have got it. So how many questions are left? Yeah, so yeah, we're almost done. We are nearing the end now. We just have 2 questions more left. Okay, I hope everyone is still charged up. So I'll increase the size of this. Okay, let's look at the question. The question says, out of 105 students taking an examination, English and mathematics, okay, 80 students pass in English, 75 students pass in mathematics. Okay, 75 students pass in mathematics. 10 students fail in both the subjects. How many students fail in only one subject? That is the question. Okay. So this question has a similar flavor to the previous one, but there is some slight things to look out for. What is the total number of students? Okay, let the universe be all students. Okay. Now, what is the size of the universe? There are 105 students in this universe. Okay, good. 80 students pass in English, 75 students pass in mathematics. Now, remember that I cannot. It is not enough to take my set as all the students who take English and all the students who do not take English. All the students who take in mathematics as my sets, because here we are talking about passing and failing. Remember that. I need to somehow account for these information also in my sets. So I'll do simply that. Okay. Let E be the set of all the students, okay, such that X passes in maths. Good. Let us call it M. Why am I calling it E? Then the other subjects is English. That's why I called it E. Passing in English. Next, let M be all the students such that they pass in mathematics. Good. Okay. So immediately what do we have? The question says 80 students, 80 students pass in English, 75 students pass in mathematics. This means by the question, size of E equals 80 and size of the number of students who pass in maths is 75. Okay. Now 10 students fail in both the subjects. Okay. Now what do I mean by that? Yeah. Let's see. So this is my Venn diagram. This is for English and this is for maths. These are students who pass in English. These are students who pass in maths. These are the set of all the universe of all students. Now, how many students here? 80. How many students here? 75. 10 students fail in both the subjects. You see that these are the students who pass in both the subjects. These are the students who pass in English but not in mathematics. These are the students who pass in mathematics but not in English. 10 students fail in both the subjects. These, the ones outside E union M, are exactly the students who, okay, these are the students sitting in this area, okay, are the students, okay, who fail in both the subjects. 10 students. So 10 students fail in both, okay, 10 students fail in both the subjects, okay, English and mathematics. So who are these students? These students, as we observed in the Venn diagrams, are E union M whole complement. All the students who are sitting outside E and M complement, sitting outside this. Can you get? This is equal to 10. All the people sitting outside. What does it mean? So if E union M complement is equal to 10, then 10 people sitting outside. This implies that E union M, what is the size of this? The size of this is simply the universe minus the people sitting outside. The size of this part is simply the universe minus, people sitting outside, right? E union M, otherwise you can even use this, okay, minus U minus by definition of complement, which implies size of E union M is nothing but size of universe minus the size of E union M whole complement. Okay, good. Now what do you have? Which is equal to size of the universe. How many students are there? 105. 105 minus E union M whole complement. What is the size? 10 students, which is equal to 95. So size of E union M is equal to 95. Now what is the question asking? How many students fail in only one subject? Okay, now I'll ask a conceptual question. Okay, these are the students that pass in English. These are the and these are the students who pass in mathematics. Who are the students, okay, in terms of E and M, who fail in only one subject? Can someone answer that? These are the students who pass in English, okay, and these are the students who pass in mathematics. I want to know all the students who fail in only one subject. Or to make things simpler, pass in only one. Okay, Akanksha is saying E symmetric difference M. E complement symmetric difference M complement. Okay. Okay. Anyone else? Divya, Taswar, Tehseen. Okay, so I'll explain it to you. Okay, Akanksha has said E complement symmetric difference M complement. Okay, why is it E complement symmetric difference M complement? So E complement are all the people who failed in okay. So yeah, I'll address this. Okay, Akanksha. I mean, you are along the correct lines, but so let's see what E complement symmetric difference M complement means. Okay, what is E complement? All the people that failed in English, symmetric difference, all people failed in maths. All people that failed in English, symmetric difference, all people who failed in maths. And what is meant by I'm taking the symmetric difference? I want to remove their overlap. I am, which is, all fails minus all who failed in both. All fails minus all who failed in both. Okay, this is what I mean by symmetric difference. The question is asking failed in only one subject. So if I remove who failed in both, obviously I'll get the answer. So yeah, you are correct, Akanksha. It is E complement symmetric M complement. That is correct. But another way I can also see it is, okay, another way I can also see it is, okay, failed in only one subject is same as passed in only one subject, right? Failed in only one subject is same as passed in only one subject. So I can only look at passing. Who are the people who passed in only one subject? People sitting here. So, which is nothing but the symmetric difference. So E symmetric difference M is also a correct answer. These are the people who passed in only one subject. In other words, they failed in only one subject because there are only two subjects. But if there were more subjects, then your answer is the more correct answer because I can not use this logic anymore. Okay, good. I hope everyone is clear with this. What is E symmetric difference M? It is simply E union M minus E intersection M. Okay, the size of symmetric difference is simply E union M minus E intersection M. I know what this is now. I want to find this. Okay, so I need to find E intersection M, size of E intersection M. Can someone quickly find it now? These are the values I have. Can someone tell me what E intersection M is? Okay. So source is 60. Okay, let's verify if it's true or not. Okay, we need to find E intersection M. What I'll do is, by the principle of inclusion exclusion, size of E union M is nothing but size of E plus size of M minus size of E intersection M. What is that? Size of E is 80 plus 75, which is the size of M, minus E intersection M. This is what I need to find. Now what I do is, E union M, what is the size of E union M? 95. So this is 95. Now I bring E intersection M this side, is equal to 80 plus 75 minus 95. What is 80 plus 75 is 155 minus 95. So what is 155 minus 95? 0 here. 15 minus 9. 6. Yeah, good Taswar. It is 60. Finally, I simply apply this observation here. This is what I need to find. So number of people failed in only one subject is equal to E union M, size of E union M minus E intersection M, which is equal to 95 minus 60, which is equal to 35. Is the option there? Yeah, so C is the answer, 35. I hope it is clear. So it's almost 8 now. So yeah, I think we are running out of time. So this is the final question, but I think we are running out of time. So although this is a direct application, do like maybe screenshot this question, or even the document will be shared later, don't worry. So try solving this, okay, offline. And this uses another principle of inclusion exclusion. It is pretty straightforward. It is direct application of the formula. Okay, so yeah, I will wrap up the session now. Okay, I hope that the problems that I solved today were interesting. Okay, and set theory is a pretty interesting area. I mean, later on in higher mathematics it is used quite a lot. Yeah, Tessin, did you raise your hand? Tessin.
Sir, I have not attend today's class. तो सर वो लास्ट वाली जो मतलब नोट्स है वो मैं कैसे लूंगी?
क्या 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 लास्ट वाले क्वेश्चन में क्या करोगी?
ये सर जो आप सॉल्व कराई है।
कौन सा? ये प्रीवियस वाला क्वेश्चन बोल रहे हो, ये वाला? या
सर ये बेटन 7 PM एट
7? ओके, तुमने 7 PM में ज्वाइन किया था?
एट 7 o'clock।
ओके, 7 o'clock में ज्वाइन किया था तुमने। सो तुम प्रीवियस क्वेश्चन का बोल रहे हो, उससे पहले का क्वेश्चन?
यस सर।
ओ अच्छा, तो बट तहसीन अभी तो हमारे पास टाइम कम है, ठीक है, लेकिन
सर
क्या
सर वो नोट कैसे मिलेगी?
हाँ, तो अनाउंसमेंट आया था। आई थिंक रेस्ट ऑफ यू कैन कंफर्म, राइट? अनाउंसमेंट आया था इसमें, आई थिंक वो NPTEL में। तो उसमें क्या होगा कि तुम्हारा लिंक दिया है, ओके, जिसमें तुम्हारा सब शेयर होगा। बट एनीवे, मैं क्या करता हूँ ना, अभी चैट में मैं शेयर करता हूँ, ठीक है?
यस सर।
चैट में वो देखो, हाँ, मैं चैट में शेयर कर रहा हूँ, रुको।
सर एक और क्वेश्चन पूछनी थी आपसे।
हाँ बताओ।
सर जावा का हम लोग का ऑनलाइन क्लास होता है, उसका कोई सेशन लाइव सेशन नहीं होता है क्या?
उसका तो आई एम सॉरी तहसीन, उसका इंफॉर्मेशन मेरे पास नहीं है। सो वो टोटली डिफरेंट कोर्स है। तो उस कोर्स में जो मतलब फोरम्स है, उसमें एक बार पूछ लो ना उसका, ठीक है?
जैसे डिस्क्रीट मैथमेटिक्स का क्लास है तो लिंक आ जाती है इसकी, लेकिन उसका कोई लिंक ही नहीं आया। मैंने अभी तक कोई क्लास ज्वाइन भी नहीं किया जावा का।
अच्छा, तो वो NPTEL को एक बार मेल कर लो, ठीक है? NPTEL टीम को एक बार मेल कर लो। मतलब मेरा जो स्कोप है वो तो बस इस कोर्स के लिए है। सो इस कोर्स के बाहर जो होता है उसमें मुझे कुछ नॉलेज नहीं है। सो आई विल नॉट बी एबल टू हेल्प यू सैडली, ठीक है?
ओके सर।
सो बट फिलहाल के लिए मैंने ये चैट में वो ड्राइव का लिंक शेयर किया है, ओके? द रिमेनिंग ऑफ यू कैन आल्सो चेक, ठीक है? ड्राइव का लिंक शेयर किया हूँ, इसमें ये नोट सब अपलोड होंगे।
सर एक और आपने कहा था कि YouTube पे कोई चैनल वगैरह के लिए लिंक शेयर किया जाएगा।
हाँ, वो उसका भी अनाउंसमेंट आया था एक्चुअली NPTEL में। बट मैं उसका भी शेयर कर देता हूँ, ठीक है? 1 मिनट रुको, मैं उसका लिंक भी शेयर करता हूँ। ओके, हाँ, तो हाँ, ओके, सो दिस इज लास्ट टाइम्स यूट्यूब लिंक, ओके?
ओके सर।
तो ये लास्ट टाइम का वो है। दिस इज चैनल लिंक तो नहीं है, बट आई कैन शेयर यू द चैनल लिंक ऑल्सो। How do I share it? Okay, here. Wait. हाँ, ये है मेरा चैनल का लिंक, ओके? यूट्यूब चैनल का, द फाइनल लिंक दैट आई सेंट, ठीक है?
अच्छा सर।
इसमें
Thank
जो
you, sir.
जो भी है पूरा सेशन का पूरा रिकॉर्डेड है, ठीक है? लास्ट टाइम का रिकॉर्डिंग में इशू हो गया था, तो मैंने फिर से रिकॉर्ड किया। तो लास्ट टाइम का लाइव सेशन का रिकॉर्डिंग नहीं है, लेकिन सिमिलर रिकॉर्डिंग है। जो भी मैंने लाइव सेशन में किया वही चीज़ है, ठीक है? और ये भी जो है,
Okay.
मतलब अंटिल टुडे, टुनाइट और टुमारो मॉर्निंग ये अपलोड हो जाएगा वहाँ पे।
Okay, sir.
Okay then, ठीक है तहसीन. Okay then everyone, we'll be winding up the session. It's almost 8 o'clock now. Okay, now have your dinner, I guess. I hope you were interested in the things I taught today. And next week's session is on logic, and it will be being held on next Tuesday 6 p.m. to 8 p.m. Okay? Okay then.
Sir,
Yeah.
week में
Thank you, sir.
Okay, thank you
one
Taswir.
class होगी।
Yeah, Tassin. Thank you.
वीक
Divya.
में सिर्फ वन होगी ना?
वीक में
वन क्लास लाइव क्लास होगी।
या तहसीन एक दूसरे टीए भी है, हिज नेम इज सूर्यदीप नाथ, और उसका मंडेज में होता है, मंडे 6 PM में होता है।
अच्छा।
ओके,
नहीं सर, कल एक और लिंक आई हुई थी मंडे का, मतलब जूम पे, लेकिन उसको टैप मैंने किया था तो हो नहीं रहा था वैसे।
अच्छा, ओके ओके, मतलब प्रॉब्लम नहीं है, यू कैन अटेंड आइदर और बोथ ऑफ द सेशंस। जो डिस्कस होगा, मतलब क्वेश्चंस तो डिफरेंट डिस्कस होंगे, लेकिन जो जो कंटेंट डिस्कस होगा वो सेम वीक का ही कंटेंट होगा, ठीक है?
अच्छा।
तो तुम ये ट्यूसडे वाला भी कर सकते हो और वो वाला भी कर सकते हो, या दोनों कर सकते हो अटेंड। ओके,
वीक में एक ही क्लास होगी लेकिन।
हाँ, एक एटलीस्ट मैं वीक में एक ही ऑफर करूंगा, ठीक है? ट्यूसडे 6 PM।
नहीं, इसकी पिछले बार सेशन में 2 सेशन मतलब लाइव सेशन हुआ करती थी, एक सैटरडे एक शायद ट्यूसडे को।
हाँ हाँ हाँ, इस कोर्स में भी ऐसा ही हो रहा है, बट मंडे और ट्यूसडे को हो रहा है।
अच्छा,
ठीक है,
मतलब क्वेश्चन सेम रहता है?
क्या सेम रहता है?
क्वेश्चन सेम रहता है, मतलब सॉल्व सेम ही कराया जाता है? कल भी सेम ही रहता, आज भी?
नहीं नहीं, डिफरेंट रहता है दोनों में। कंटेंट सेम होता है, क्वेश्चंस डिफरेंट होता है।
ओके सर,
ठीक है,
थैंक यू सर।
ओके, थैंक यू तहसीन। ओके, बाय
हिंद।
तहसीन, बाय तस्वर। ओके, हाँ, जय हिंद तहसीन। ओके, गुड नाइट।
Good night, sir.
ओके, गुड नाइट तस्वर।